Hello, my name is Markus Ohlenforst and I'm one of the two managing directors of IconPro. In this video, I would like to show you how you can enable condition monitoring and predictive maintenance in your production for your measurement machines, machine tools, or robots. IconPro Apollo can do this for you in less than 30 days. It runs in cloud or on-premise and it helps you to more operator efficiency, more machine utilization and machine reliability, and less maintenance efforts. So let's start. So Apollo is a web application. So first that we see is the sign-in screen. So here we have to type in our username and the password, and then we can sign in. So first that we see after signing in is a device overview. Next to the device overview, there's also a service overview and a program overview as the two other main views in Apollo, but this I will show later. In summary, the device overview shows us the most important information that there is about the currently connected machines. So we can see here that every machine is represented as a card, and each card then shows the operational status like running, idle, or also error, and the program execution, the current program execution status, as well as conditions like is the temperature okay, is the humidity okay, is the vibration okay, or was there a collision? Apart from that, we can see two other icons that refer to the certification or the health status of the individual machine. But more about that later. On the top right, we can see the event log. So here we can see all the events and alarms that occur for any of the connected machines. And we can also subscribe to them. For example, subscribe to any collision that happens or subscribe to any program execution error that happens, like here. So here we actually can derive from if there is any problem right now for any machine occurring. If we want to know how the operational status was recently as a history, so what happened for my machines in the last 8 hours, for example, but here we can also switch to up to the last 3 months, then this is shown here in the utilization over time plot. Here we can see for every machine how the operational status changed over time. Here for the last 8 hours, so for the time span that I configured. Obviously, sometimes the machine is idle or running, and then it's maybe in an error state before it switches to running again. So this is something that we can see here. On the bottom right, we see the summary of how effective are my machines working. So if I ask myself, is not only if everything is fine, but how utilized my machines are, then I can quickly see via the overall equipment effectiveness evaluation. Here it is 27%, which is not too good actually. And we can see here that this is mainly due to one of the sub-parameters of the OEE, namely due to the availability. So here the OEE is not so good because of the availability being not so good. Availability means that here only 30% of the shift time that I configured, so we can, by the way, edit shifts for the machines, so that only 30% of the shift time the machines are in a running state. And 70% of the time, obviously, they are in an error or in an idle state. The performance or the quality metric, on the other hand, they are quite fine. Performance gives me the value or the information about how high the speed of the execution of the programs is. So 100% would mean that all the machines execute all the programs in the ideal time, and 50% would mean that they need double as much time, while the quality shows us here that 92% of the machines complete, or that 92% of the programs that are started are completed successfully by the machines. So as said here, it's due to the availability that the OEE is not so good. And if we would ask ourselves now, why is that actually? A first answer we can get via taking a look at the queue time or the setup time. The queue time metric here tells us the time that is an average needed to switch from one program to the next of the same program. The setup time tells us how long an operator needs to switch after one program is ended to the next different program or to the next different part. So this actually is time where the machine is idle, and therefore this influences the availability of the machines and with that also the overall equipment effectiveness. This is one way to explain it. Another way would be, of course, to take a look here at the utilization timeline, or to take a look at the share, or at the absolute time that the machines are in error state, or to take a look at the OEE info here, at the OEE info tab, where I can sort the machines according to their quality, for example, where I can see the machine with the highest quality, or where I can see the machine with the highest performance or with the highest availability, and then also identify machines that are not as good as, for example, this machine here. I can also sort them according to their setup time or to their queue time to see which machines do need not so much time for setting up the next part, or do need especially much time to do this. So this is, in short, the device overview that you can access first when signing into Apollo. So to investigate what kind of issue there is, if you see any issue here, and to drill down to the reason, there is a possibility to get from the device overview into the device detail view. For this, we search a machine now which shows some problems like this one. For example, here it shows a temperature warning and a critical collision, and we just click on this card and we get into the device detail view. So here now we see all kind of information that is just referring to this specific machine. So to make it easy, we can just click here on this icon, which shows a critical collision. And then we directly get to the plots showing us all collisions that happened. We can also select here just the last week, for example, and then we only see the collisions of the last week. And we can see here that there were some collisions which actually exceeded the configured critical limits here in red. These are configured by defining a certain threshold value for the speed with which a collision may happen, and for the deflection. Here in this case, it's a coordinate measurement machine. So here we are talking about a touch probe collision. So we can then go to the event log here and also filter out the events that refer to these collisions to see when this actually happened last time. For this, we select the sensor here and the error level and apply the filter, and then we can see when this collision actually happened. We see the date here, and we also see some information, like for example also that the gripper of the touch probe of this coordinate measurement machine opened due to this collision. We could then also, via the events, filter out the measurements or the programs that were executed right after the collision. But however, there is actually no reason to worry about, because we can see that the health status of the machine is still okay, despite of the collision here. So the collision status can be set back by an administrator, for example, by the measurement room lead and by no one else. So by this, you can actually make sure that you get notified about any collision that happens to any of your machines. You can even subscribe to those collision events that we have seen, so that you get an email when a collision happened. So what you would normally do after a collision is to check if the measurement stability for this coordinate measurement machine is still okay. And this we can do here via the measurements tab, where all the measurements of this machine are shown for the configured artifact or for the configured calibration part or program. And here we can see that the current status of the machine is within the limits. There is one critical parameter, or there are some measurement parameters that are measured, but here the only one that is in there is actually fine and within the limits. There was some kind of change point at some while ago, but everything is fine. The historical points show that the machine is within the conditions, and the prediction here shows that the machine will also stay within the limits for the next time. This is how you can drill down to problems regarding sensors or the health status of the machine, and also predict the near future based on the example of a coordinate measurement machine. So we can do the same as well for machine tools. where you, of course, don't have any measurements, but where you have all the sensors like temperature or vibration or collision in the same manner. Next thing that I would like to show to you is the program overview tab. So this is the one up here. In the program overview, it is about the operational perspective onto the machines. Doesn't matter if it is a measurement machine or a machine tool. What we can see here is different cards that do not represent machines, but programs that are executed. And one program or one card can refer to multiple machines at the same time if the same program is executed by multiple machines. This is what we can see here. On the right side, we see the event log, which now here by default only contains events that are somehow program related. And in the bottom, we see a nice statistics table, which shows us a lot of interesting information. What we can see here is all programs and the different devices on which they are executed. We could, for example, see in a certain time period, like here in the last 8 hours, which program was executed how often. And we could, for example, see that this program here was executed with 19 times the most often. We can see when it was last run. We can see the average runtime of this and the average downtime due to program pauses, for example. We can see its average performance, which is here pretty good. We can see the quality telling us that here 84% of the routines of this program were actually completed successfully without any error. If it is a measurement program, we can see the yield rate, so how many scrap parts were actually there. Here it's, of course, the yield is not scrap parts or the good parts. Here 100% of the parts are okay. And we can also see the queue time, meaning the time that it took in average in between the executions of this program. And we can also see something like the average throttle. This is interesting, especially for machine tools, and tells us actually how the throttle configuration in average was for this program. This could explain, for example, if the performance would be a little bit lower. So here all the performances are fine, and therefore we can see also all the throttle configurations are either 100% or very close to it. Now let's take a look at the program detail view. To get to the program detail view, we click on one of the cards in the program overview or on one program in the statistics table. Then we get to a view like this here. So we see the program that we selected. We see now information that only refer to this program. We can see on which machines this program is executed. In this case here, I selected a measurement program, which is executed on multiple coordinate measurement machines. We can see here the events only for this program, like the program started, completed, or paused events, or sometimes also execution errors. And I can also see different information here, some meta information like the ideal time, ideal execution time of this program, the average runtime, and the average downtime. I can see here that the performance of this program, so the speed with which it is executed, is very good. So there is a quality of 89%. So here 11% of the executions of this program do not finish successfully. This is something that we can take a look at here later. And we can see the yield rate, meaning here that there is actually no scrap that was measured in the time span that I configured here. Below, we can see all executions of this program. So we can see here when was it started, when was it ended, what was the downtime associated with it. We can see the runtime and also the status. So here, for example, we can see already a machine that was not completed. If we click here on this play button, then we can see more information about this execution. So here we can see the program was started at some point and then someone canceled the program out of which reason soever. And this is the reason why it did not finish successfully. And this is also why the quality metric suffers a bit. So if we would take a program execution that was actually completed and that was also passed because the measurements were showing good quality results. This we can, by the way, also see by clicking on this icon here, that we can see, okay, there is actually only one parameter in here and there was no deviation measured. So therefore this was okay. So then we can also click here and see the measurement results, the exact measurement results for this program execution. Also, if there would be multiple parameters, of course, and we can also export this here as a CSV file, as a report, if we want. Interesting also is that because in Apollo you already have all the measurement data, if it is a measurement machine, you can also evaluate the process capability quite easily. This is something that I would like to show you here. So by clicking on the process capability and by selecting now a machine that we would like to take a look at, we can get the quality control chart here for the time span that we configured, including the CP and the CPK value. And we can also take a look at the histogram that is associated with it, and this which is evaluated automatically by Apollo. In other words, Apollo also provides a basic Allied SPC module that just comes with it for you to be able to evaluate CP and CPK values based on the collected measurement results. Next, I would like to show the last but not least tab to you, which is the service overview. The service overview can be found by clicking on the service overview tab here. This gives you all information at one glance that is relevant about the service needs of your machines. So all machines are listed here. By the way, machines can be grouped. So therefore we see them grouped here to the different groups that were configured here in our demo environment. And we can also see the last service activity for each machine. We can see the predicted out of specification date, if there is any for any machine, like for example here. And we can also see the reminder for the next necessary service activity. So here we see one in red, remembering us, okay, here a service activity is needed in the near future. We can also see this here in the event log, and we can now either click on the machine or to directly add a service activity and perform a service activity, document a service activity, or we can go here to see more service relevant data of metadata of this machine. Let's first go to this machine here. I already opened it here. And what we can do here is we can actually go to the service activity management and see here already configured service activities of the past for this machine. We can see here that a report can be uploaded for each service activity that is executed, for example, a calibration protocol. And we can also see that we can add another service activity. So for example, if there was a collision of a machine or if a machine is out of spec, then we could add a service activity here, for example, a calibration, which then makes the machine reset, meaning that the machine goes into a green status again. And I can also upload a document to protocol the service activity that I have done. This, of course, can only be done by administrators or by users with the according rights. I can also assign service templates to machines so that only certain service activities are possible. But this is it, what I want to show you here right now. Let's go back to the service overview, which was here, and click on one machine. We can then see here suddenly all the system information that could be relevant for a service department. Like for example, the serial number, we can see the model of the machine, the location, we can see some kind of ID, we can see the controller information of this machine with the last firmware version. We can see the software update history of this machine. We can see the sensors that are applied to the machine, including their limits. And we can also see here the service activity history. All of that can be downloaded by just one click, by clicking here, or we can also directly request a service if Apollo is here connected with an according mail server, which it is here in my case. I can then here include the upcoming activities and also the metadata and the events of the machine and then directly send a ticket to the service department so that the service department has all the information that are needed to prepare for the service activity and to schedule it. This is what I wanted to show you about the service overview and the service detail view in Apollo. If you want to have more information about the connectivity of Apollo with common coordinate measurement machine types, machine tools, or robots, please visit our webpage iconpro.com to read about it or to contact us. We also offer access to our demo environment or proof of concept installations for your use case. Thanks for listening, take care, and goodbye.